All right, so let's pick up with number 18. You can see how this one is a little different from the other problems that we did. So we got 2 sine of x is equal to tan x. So this time we're going to use a different trig identity. We're going to use a quotient identity. So tan x is equal to sine x over cosine x. You're going to see, as we typically go through with the trig identities, that usually turning things into sines and cosines helps you out more than leaving tangent or some of the other functions. So let's see how we can go ahead and use this. So I got 2 sine x is equal to tan x. Well, if I go ahead and replace tangent x with sine x over cosine x, I'm going to do that now. Got 2 sine x is equal to sine x over cosine x. So now someone's saying, well, you just replaced a trig function and now you have still 2 different trig functions. You got sine and cosine. Yes, but look what we can do here. I can get rid of this cosine x if I go ahead and multiply both sides by cosine. So I'm going to go ahead and multiply this side by cosine x, multiply this side by cosine x. So that gives me 2 sine x cosine x is equal to sine x. And then when I go ahead and set this equal to 0, so I subtract sine x, that gives me 2 sine x cosine x minus sine x is equal to 0. So still you might be saying, well, I don't see how that helps us at all. Well, if you look here now, I got this term and this term. They both have a sine x. So I could take out a common factor. If I do that, that gives me sine x times 2 cosine x minus 1 is equal to 0. So again, if I factor out a sine x, factor it out of here, then that leaves me with just 2 in cosine x. If I take out a sine x here, it just leaves me with the 1. Well, now look, I have this term in the front, sine x, and then I have this 2 separate factors that I can set equal to 0. So even though I have the 2 different trig functions, I can still solve this because they're separated into different factors. So I'm going to go ahead and set this equal to 0. So I got sine x is equal to 0. And then 2 cosine x minus 1 is equal to 0. So this one's already solved. I'm going to go ahead and add 1 here. And I get 2 cosine x is equal to 1. Go up a little bit. Divide by 2. And then cosine x is equal to a half. So here at sine x equals 0, hopefully it seems familiar to you at this point. Again, you're going to be on the axes is when is sine x equal to 0. That's going to happen here. That's 1 comma 0. Remember, the sine value comes from the y coordinate. So it is at x equals 0. So that takes care of that. And then cosine x equals a half. Again, if you go to your unit circle, and if you think about the quadrants, you get all students take calculus. So when is cosine positive? It's positive in 1 and it's positive in 4. And then in quadrant 1, again, getting the 1/2, hopefully you recognize that that happens at 60 degrees, which is pi over 3, because again, our answer is from 0 to 2 pi. So here, this happens at pi over 3, and then this, of course, from here to here, if you're thinking of a reference angle, would be pi over 3, or if you go directly to the unit circle, that happens at 5 pi over 3. So this cosine x equals 1/2, so it's at x equals pi over 3 and 5 pi over 3. So then our answer is basically just x is equal to 0, pi over 3, and 5 pi over 3. All right, so let's go ahead and take a look at number 19. All right, so let's go ahead and take a look at number 19, and this is going to be the last problem for solving trig equations. And we did 19 examples. So if you look at here, I just kind of switched it up a little bit from what I was doing. I got a reciprocal function here just to show you that. Well, if we want to go ahead and solve this, we basically want to get the cosecant by itself. So I'm going to go ahead and subtract 3 from both sides. So I get cosecant negative x plus 5 pi over 6 is equal to negative 2. Now remember what we did before. So we're going to have this shift in here. So what I want to do first is figure out, well, when is cosecant x equal to negative 2? Well, let's just go ahead and use the reciprocal function. So the reciprocal of cosecant is sine. So if cosecant x is equal to negative 2, that means that sine x is equal to negative 1/2 the reciprocal of it. So now it's a little bit easier to work with. So when does sine x equal to negative 1/2? You can pick that up from the unit circle, or you can just go ahead and do your inverse. Now first, when is sine negative? So all students take calculus. So sine is negative in quadrant 3 and in quadrant 4. You can go ahead and figure out based on your unit circle. You can do the inverse. So if I do the inverse to both sides, so sine inverse of negative 1/2, that's going to give me negative 30 degrees, which basically means that your reference angle theta prime is 30 degrees. So this is 30 degrees, this is 30 degrees. Now remember, we're in radians here. So from here to here is 180 plus the 30. So in quadrant 3 is 210. So that is at 7 pi over 6 in radians. And then here would be 360 minus the 30, which would be 330 degrees, and that is 11 pi over 6. So now that tells us where cosecant x is equal to negative 2, but we have this change right here, this shift. So how do we do that? We correct for it. We're going to take this, and we're going to say that negative x plus 5 pi over 6, we're going to set that equal to 7 pi over 6. And then we're going to take the negative x plus 5 pi over 6 and set that equal to the other answer, which is 11 pi over 6. So this is going to go ahead and correct for the shift that we have in this equation. So when I solve this, I'm going to go ahead and subtract 5 pi over 6 from both sides. So I get negative x is equal to pi over 3. Then I'm just going to divide by negative 1. And I get x is equal to negative pi over 3. Then over here, subtract 5 pi over 6. And I get negative x is equal to pi. And then I'm going to divide by negative 1. And I get x is equal to negative pi. So we're trying to get between 0 and 2 pi. You can see that both of these answers are outside of that. Well, if I can just add the period to these and get within the range, I will find my answers. Well, remember, it's the period for the original right here. Well, the period for cosecant x is 2 pi divided by, and I'm going to say the absolute value b because that's what it is, because here you have a negative b value. So this would be 2 pi divided by the absolute value of negative 1, which would just be 1. So 2 pi divided by 1 is just 2 pi. So basically, if I just keep adding 2 pi to these, I will get somehow in this interval from 0 to 2 pi. So I'm going to go ahead and take this first one. So x is equal to negative pi over 3 plus 2 pi. And when I do that, move this up a little bit, that gives me 5 pi over 3. So 5 pi over 3. And then when I go ahead and over this side say x is equal to, I'm going to add the 2 pi here. I get x is equal to pi. So now these 5 pi over 3 and pi, they're inside this interval from 0, you can see that, from 0 to 2 pi. So I'm good. If I add another 2 pi to these, I'm clearly going to be outside. So these are my only two answers right here. So I have x is equal to pi and 5 pi over 3. And those are the only two answers that I have. All right, well, hopefully you enjoyed these 19 problems. I had to break it up. It's a lot, but I wanted to give you a good variety, and hopefully it'll help you in solving trig equations. And the next videos that we're going to be working on are trig identities. So I'll see you next time.